Hello and thank you for watching this recording. Previously, we have discussed how really there are only 5 mathematical statements when we are using the operations of addition and subtraction with integers. We talked about the fact that subtracting is the same as adding the opposite, so it can be helpful to think of the subtraction sign as instead saying, and the opposite of. So 6 minus 8, 6 take away 8, 6 subtract 8 is the same thing as saying 6 and the opposite of 8, which as you can see here is negative 2. We talked about the fact that a number line is a useful mathematical tool in solving addition and subtraction of integers. To the right of 0 are the positive integers, to the left are the opposite of the positive integers or the negative integers. So 6 and the opposite of 8, I would start to the right at 6. If it were merely 6 plus 8, I would add 8 to the right and get 14, but this is 6 and the opposite of 8, so I start at 6 to the right of 0, and I would go the opposite direction or to the left 8 places and end up with negative 2. You can review the previous videos to go back and take a look at how this worked again. Another useful tool when solving operations of addition and subtraction with integers are using manipulatives. Today I'm going to use black and red circles where red represents a negative integer and black represents a positive integer. So for this first problem, 6 and the opposite of 8 is the opposite of 2 or negative 2. You can see I have 6 black circles to represent the positive 6, and I have 8 red circles to represent the negative 8. Now, red and black circles zero each other out. They cancel each other out. They make 0 pairs, and then what you have left would be the solution to your problem. So if I match up 6 of the negatives with 6 of the positives, those all cancel each other out into 0 pairs, and what I have left are 2 red circles, which represent the negative 2. Okay, let's take a look at 4 and negative 9. I'm going to move these up here this time. So here I would have 4 black representing the positive 4, and I would have 9 red. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I need one more red one, so I'm going to just magically make this guy red. Actually, what I'll do is I'll duplicate here. There we go. Okay, 4 black, 9 red. Well, instead of going one by one this time, I'm just going to look and see how I have 4 black would cancel out 4 red. So I'm left with 1, 2, 3, 4, 5 red, or a negative 5. Okay. Next, the opposite of 7 and the opposite of 5. So the opposite of 7, 1, 2, 3, 4, 5, 6, and 7. Now, the opposite of 5 would be 5 red ones, but I want the opposite of that. So I would have 5 black ones. 1, 2, 3, 4, 5. And I'm going to look for my 0 pairs. So if I have 5 black, and I can cancel out 5 red, I am left with 2 red or a negative 2. Okay, now opposite of 3 and the opposite of 4. Okay, so we're problem number 4 here is the opposite of 3 and the opposite of 4. Well, I'm not going to use any black ones this time. I need 4 red for the opposite of 4. I have no 0 pairs to cancel out, so what I'm left with are 7 red circles representing negative 7. Now, for this last one, 8 and the opposite of 3, what if I don't have circles? Well, no worries. I can just use the letters as symbols. Pardon my writing here. It's tough to do with the mouse. So 8 black, I could have 1, 2, 3, 4, 5, 6, 7, 8 B's for blacks. And the opposite of 3 would be 3 reds. And I could cancel out 3 reds with 3 blacks. I would have 5 B's left. 5 blacks would be a positive 5. Another way to take a look at integers is to look at what we call the rules of addition and subtraction. Subtracting, again, is the same as adding the opposite. The rules they used to teach in school in the olden days were turn subtraction into addition by going same, leave the first sign the same, change subtraction to addition, and then change the sign of the last number. Same, change. The thing is you don't do that to addition, you only do it to subtraction. And then if you ended up with the same sign, you add them, same sign, sum, and take the sign that's there. If you have different signs, you subtract them and take the sign of the bigger number. So here we have all of the subtraction statements turned into the addition statements, just as we have been doing. And here's how the same, change worked. I'm just going to do it here to the left. So 3 minus 4, or 3 in the opposite of 4. Same, change, same, change, same, change, same, change. Okay, now all of these have been turned into those. And then same sign, sum. These both have negative signs. Same sign, sum, add them. Take the sign of the bigger number, 3 and 4 is 7, negative 7. Same sign, sum, 3 and 4 are positive, add them. Take the sign that's there. If I said the sign of the bigger number here, I apologize. They're both, that's the problem with using rules, you see. See how both of these are negative integers? I add them, take the sign that's there. Both are positive integers. I add them, I take the sign that's there. If there are opposite signs, subtract and take the sign of the bigger number. Positive and a negative. 4 minus 3 is 1. The bigger number is negative, so the answer is a negative 1. Opposite signs, a negative 3 and a positive 4. Subtract, 4 minus 3 is 1. Take the sign of the bigger number, positive 1. So that's another way to take a look at integers. Thank you very much for watching, and have a great day.